This is a tutorial for working out application problems using the binomial distribution. Applications usually involve calculating the number of trials or the probability of success. They are usually a little bit trickier and may involve conditional probability as well. We need to use formulae when calculating these types of questions. So let's take a look at our first question. A fair 8-sided die is tossed and the number facing up is noted. If the probability of getting at least one 8 is to exceed 0.7, how many times should the die be tossed? So in this example, we are basically asked to find the number of trials. Let's take what we know from the question and write it down in probability statement form. This shows the probability that x is at least 1 must exceed, so be bigger than, 0.7. The complementary statement to this is the probability that x equals 0 must be less than 0.3. This statement is useful because it is in point probability form, so it's about an individual case, not a cumulative range like the first statement. We also know the probability of success is 1/8. The probability of rolling an 8 on this die. The number of trials is what we are trying to work out, so we don't know that yet. Now we need our binomial formula, which I have put just up here. So we'll grab that. This also uses point probability form. You will find this formula on page 4 of your booklet. We can fill in this formula with what we know so far. Simplifying this, we get because any combination where we select 0 is equal to 1, and any number to the power of 0 is also equal to 1. So we end up with now we can take logs of both sides. And solve for n. Figuring this out on the calculator, it looks like this. Using ordinary run mode, that one there. And we're just going to enter in our equation as we see it. So we should have log 0.3 divided by log 7/8. Make sure you have the fraction in brackets. And there we have our answer that we're going to go and write down. So writing down our answer, we have so we would need to roll the die at least 10 times for this to occur. Let's take a look at our second question. A travel agent receives email messages from either within New Zealand or from overseas. The probability that any given email arrives from within New Zealand is 0.72. One day the travel agent receives 9 emails. If at least 4 are from within New Zealand, calculate the probability that only one of the 9 emails is from overseas. In this example, we are finding a conditional probability. Let's take what we know from the question and write it down. We are using a binomial distribution where our number of trials is the 9 emails and our probability of success is receiving an email from New Zealand. So that's P equals 0.72. Now we need to remember our conditional probability formula, which I have put to the side of the question. And we can write out the conditional probability that we are trying to find. So our probability statement looks like this. I've turned both parts of the probability statement to be about receiving emails within New Zealand. So instead of only one of the 9 emails is from overseas, I've turned that to be 8 of the emails are from within New Zealand, given, which is stated by the if at the beginning of the question, at least 4 of the emails are from within New Zealand. So continuing with our conditional probability formula, we can then write this conditional probability can simplify down. If we look at the top line of the fraction, we're saying the probability that x equals 8 and x is more than or equal to 4. Now, just the x equals 8 part actually satisfies both of those parts, so we can simplify it down and it becomes this. So these are the two probabilities we need to find using the binomial distribution part of our calculator. So let's work on that now. Looking at these two probabilities that I'm going to use the calculator to find, I can see that for the probability that x equals 8, I'm going to be using a point distribution. And for the probability that x is more than or equal to 4, I'm going to be using a cumulative distribution. What I notice about the probability that x is at least 4 is that I don't know the upper limit, so I'm going to have to write a reverse statement for this so I can use my calculator to find out what I need. So now I have both probabilities in a format that I can use in the calculator. So let's do that now. So we need to go to the Stat menu, Binomial Distribution, and let's do the probability that x equals 8 first. So we're going to go BPD. And I'm going to enter in my values. So x equals 8, number of trials was 9, and our probability of success was 0.72. So there we have the first number that we're going to be writing down. Now we need to work out the probability for the bottom line of our fraction. So again, we're using stat mode, distribution, binomial, and this time BCD. Changing the numbers in here, X is 3, number of trials is still 9, and the probability of success still 0.72. So here's the next number we need for our calculation. All we need to do now is work this out on our calculator. So coming to run mode, we're going to type that equation in. So it should look something like this. And there we have our final answer. Remember to put your final answer to at least 4 decimal places. And make sure you don't round too early when you're doing your working. So there's 2 examples of how to use applications with the binomial distribution.